chỉ với những cái gì liên quan tới bài học. Đây là tôi thấy bọn bạn BI 12420 này, bạn 457 này, nhiều bạn lắm. Đang dùng cửa sổ này để chat. Thế thì các bạn lưu ý nhé, những cửa sổ này là chỉ để trao đổi những cái gì liên quan tới bài giảng. Okay, now we continue. Before I need to verify something. At the beginning, when I capture the screen for the attendance checking, I do not have more than 200 students. Now I have 223. So I suppose that you were late because during the moment that I captured the screen, you were absent. So please be very careful. Here I also have some people with the camera turning off. Cao Lê Nam Anh, you turn off the camera. Nguyễn Duy Anh, for example, you turn off the camera. Yeah. So for those who are turning off the camera, I will also do not check attendance for you guys. Yeah, is it clear for you? So if you still keeping turning off the camera, you are considered to be absent from my list. No, I do not accept any excuses. If your camera is broken, you can use your mobile phone. If you know that this one is broken, you should prepare. You borrow another one, you buy another one. This is not the first day we use Zoom. Okay? The first step. The second thing, there are still people who do not name the Zoom correctly. Đặng Minh Hạnh, for example, I don't know who you are. Nguyễn Gia Thịnh, for example, I don't know who you are. Sao lại có Miss Vân ở đây? I capture during any time, any moment when I teach you, okay? I don't know how about the rule of Miss Vân. This is my rule. You should have your camera turning on during the class. That's all. You should have your Zoom name. Yeah, a correct Zoom name. That's all. Otherwise, I will not accept you in my class. Các bạn cần phải có camera mở trong lớp học của tôi. Các bạn cần phải đặt tên Zoom của các bạn đúng. Có vậy thôi. Còn nếu không thì tôi sẽ không tính là các bạn có mặt. Chứ tôi không cần biết là các bạn chụp vào lúc mấy phút hay bao nhiêu phút, tôi check bất kỳ ở trong toàn bộ cái khoản của tôi. Nguyễn Gia Thịnh, are you here? Nguyễn Gia Thịnh. Okay, I will kick him out. Đặng Minh Hạnh. Đặng Minh Hạnh. No. Wait for me. Yes, someone has a question, please.
So it has a lot with this jet.
I cannot hear you well.
Has the lesson reviewed yet, or is it just some waiting?
I cannot hear you. I cannot hear you at all.
Has the lesson reviewed yet?
Can you type it?
Okay.
Type the question. Yes, please. So I can answer you. Đặng Minh Hạnh, are you here? Oh, come on. We already resumed our lesson, okay? And now I'm checking your attendance. And for people who do not answer me, who do not have a correct name on Zoom, or the camera is still turning off, yeah, I'm trying to check if these people are really in my class or not. If they are not in my class, I kick them out and they are considered to be absent. So then if your laptop is broken, you can use your mobile phone. Even if you're going out, you should keep your camera turning on. That's all. No excuse for me. Nguyễn Trường Giang. Nguyễn Trường Giang. No? Yes, another one has a question. Please, please. Who is it? Again, Nguyễn Trần Ngọc Khánh. You again. Please.
Yeah, I'm here. So I'm here.
Okay. I thought you had a question, another question.
No, I just think that you're just asked me a question related to the lesson. So yeah, I tried to raise it.
Okay. Please wait for me a little bit. So I'll try.
Em ơi thầy. Em ơi thầy, Nguyễn Trường Giang có ạ.
Em thưa thầy, Nguyễn Trường Giang có. Nãy tôi gọi thì có thấy gì đâu.
Lúc ý em vừa đi ra khỏi phòng ạ.
Tôi không chấp nhận những cái là tôi vừa đi ra khỏi phòng nhé. Tôi bảo nghỉ 10 phút và sau đó là tay quay lại ra gặp. Chứ không phải là em nghỉ 15 phút, em nghỉ 20 phút nhé. There is no excuse for me. So you should know the way I work with you, okay? Okay? Because I'm the one taking care of you for the whole year, not only this subject. Okay. So we continue. Please wait for me. We continue. I'm replacing the cameras. Now we have seen together some basic concepts, the state, the process path, and now we go to another important basic concepts, the reversible process and irreversible process. Irreversible process. We have a reversible process, which is a process that can be reversed. Okay, in order to obtain the initial state of a system. So we have the initial state of the system. It changes to another state, but then it can always go back to the initial state. So we have a reversible process. For example, we have the uniform and slow expansion or compression of a fluid in a piston. So we know that for the piston, we can go back to the initial state, having, for example, the same volume inside the piston, the same temperature and the same pressure inside the piston. So we can go back to the initial state. Inversely, we have an irreversible process. So we know that in this type of process, the system cannot be resolved. Once we change the initial state, it cannot go back. Okay? It cannot go back. Yeah, for example, we can have the extra heat transfer. We can have the diffusion of electricity flow through a resistance. Once already distributed, the electricity flow cannot be reserved. Okay, cannot be reserved anymore. Or the heat transfer. So we know that the heat is transferred from what? From a hotter place, right, to a colder place. So once the heat is already transferred, it cannot be reserved anymore. Okay. Actually, you can go for several minutes. You do not need to ask, but you need to keep your camera turning on to avoid that. Yeah, to avoid that I'm here, I speak to you, but you are, I don't know, you are sleeping or you are doing something else. I want you to avoid that. Okay, because this is not the first day we use Zoom. And this is also not the only day that we have to use Zoom. So I want to be sure that you stay focused with me. Yeah, I take a lot of time preparing the lesson. So I want to share the knowledge with you. And I don't want to see some of my students who are not even here, but pretend to be here. Okay, this is why I ask you to have your camera on when I ask you, and also always to have the mic also on to be able to participate in the class, really to participate in the discussion. Yeah. Tôi không muốn là các bạn, tôi chuẩn bị bài giảng, chúng ta nói chuyện với nhau, nhưng mà lại một số bạn sinh viên, các bạn giả vờ là các bạn đang tham gia vào lớp. Trong khi đó là các bạn đang làm gì thì tôi lại không quan sát được. Các bạn đang ngủ hay các bạn đang làm gì đó, đúng không ạ? Thì đó là cái tối thiểu mà chúng ta tôn trọng nhau ở trong lớp này, nhất là một lớp học Zoom mà khi mà có ít sự tương tác. Và khi mà các bạn có mic, các bạn sẵn sàng luôn có mic ý, là để cho khi có bất kỳ câu hỏi nào các bạn có thể tham gia được luôn vào cái cuộc trò chuyện ở trong lớp. Đó là cái mục đích mà vì sao tôi yêu cầu các bạn có hai vấn đề đó. Đó. Okay, thank you. Now we continue. Actually, I'm having a problem of arranging the small screen. Now I see your cameras. Okay, I see your faces, but I cannot move it because it is hiding some of the information on my slide. I'm trying to fix it. Làm sao để tôi move được cái này? Đây là ok, vào một góc. Good. Let's continue. Using the new slide. We already mentioned about the thermodynamic equilibrium, right? When we talk branches of thermodynamics. So the thermoequilibrium, okay, this is a state, okay, of a system. We call it, this is a balanced state. So in this state, there's no tendency for the state of the system to change spontaneously. So the state of the system tends to remain unchanged. In this case, we have attained a thermodynamic equilibrium. For example, here, maybe we have the gas in a cylinder with a movable piston. This system, I mean the gas and the cylinder, this system will be at equilibrium if the temperature and the pressure inside are uniform and if the restraint force of the piston is just sufficient to keep it from moving. Okay, then we have a thermodynamic equilibrium for the system of the gas and the cylinder. Similarly, we may have the thermoequilibrium. So when we talk about the thermal, we talk about heat, right? For example, here I have an example of the hot place and the cold place. If the temperature of the two are the same, so there's no heat transfer anymore. In this case, we call that we have a thermal equilibrium. Or we may have mechanical equilibrium. For example, this is the case where we put a ball, okay, on the top of something like this, and it is not moving anymore. When it is not moving, we may have mechanical equilibrium. If it is falling down in both sides, then there's no mechanical equilibrium. How about chemical equilibrium? I think you are quite familiar with chemical equilibrium. Mời bạn Dương Thị Thùy Trang nào. What do you understand by saying chemical equilibrium? I cannot hear you. Okay, please. Yeah, now I can hear you. Oh. Yeah.
Sorry, I have no idea.
Oh, you have no idea. Okay. Here, you have the chemical equilibrium, right? This is the case when, for example, you have a substance A react with a substance B. It will give you a substance C and a substance D, right? So when you have the chemical equilibrium, when finally we have the substance in the A and B, yeah, and C and D, when there's no change of the mass of the products, right? The mass of the products doesn't change anymore. At the end, we have this stable mass of A, stable mass of B, stable mass of C, stable mass of D. So we can say that we have a chemical equilibrium. Yeah, no change in the mass of the products of the reaction. Bạn Lê Ngọc Tuấn làm gì nhỉ? Tập thể dục à? For the same, we may have the phase equilibrium. Okay, we know that the substance may change from solid to liquid to vapor. When it stops changing the phase, then we have the phase equilibrium. So these are some like thermodynamics equilibrium that you can tell the thermal equilibrium, mechanical, chemical phase equilibrium when we study the thermodynamics. Okay, so this is for the first part. I hope that you already captured some terminologies, important terminologies, and also some basic concepts. Okay, here if we look at once again, if we look at on the slides, the basic concept, we talk about open system, we talk about closed system, isolated system. Okay, macroscopic system, microscopic system, and also properties related to a macroscopic and macroscopic system. Okay, we talk about the intensive or also so-called the intrinsic properties, properties that are independent of the mass, and also extensive properties. These properties are dependent of the mass of the substance. Then we have the state. Okay, we have the process, we have the process path, we have reversible process and irreversible process, and also we have the thermodynamic equilibrium. So I hope that you capture it all, because we need to speak the same language, the thermodynamic language, for us to understand each other. Now we go to the second part of the session today. When we talk about the temperature, the heat, and the first law of the thermodynamics. First law. The outcomes of this part. So you should be able to understand the concept of temperature. Here I just remind you, of course, because you learned it during high school already, the concept of heat also. And you should be able to learn about the first law of thermodynamics and apply the first law of the thermodynamics. You should know what is it, what does it tell us, and how to apply it. Okay, let's go. So the temperature. Actually, this is the degree or intensity of heat present in a substance or object. So you know about the temperature. This is the degree or the intensity of heat present in a substance. So we know that if we have a high temperature, we have a high intensity of heat that is present in that substance, right? And you also know that the temperature is actually one of the 7 SI quantities. Okay, what does SI stand for? Maybe Lương Thị Ngọc Diệp. What is SI? The SI. Bạn Lương Thị Ngọc Diệp nào. Cannot hear you. Are you talking? Can you verify your mic? Because I cannot hear you at all. No? Diệp ơi. Lương Thị Ngọc Diệp ơi. Cô đang nói nên mà sao chẳng nghe thấy gì cả.
Chị có thể gửi câu hỏi không?
So I'm talking about the temperature. And I said that the temperature is one of the 7 SI quantities. And I ask you, what is the SI? What is written here? What is the meaning of the SI? SI quantities. What is written here?
Sorry, I don't know.
Tống Thị Bích Ngọc, Tống Thị Ngọc Bích.
Yeah. SI quantity là 7 đại lượng, nó gọi là đại lượng cơ sở của vật lý ạ. Em chỉ nhớ tiếng Việt là như thế luôn đấy.
In English, actually, SI, why we have the SI? S stands for system. I stands for international. System international. Okay, this is French, but normally we call also the SI quantities. System international, des unités. Hệ thống, system là hệ thống này, international là quốc tế này, các đại lượng. Okay. So this is one of the 7 SI quantity, basic quantities, of course. Yeah, in English, International System of Units, but we call it SI because this is in French, Système International des Unités. Thank you so much. So the temperature, we know that it can be measured. Okay, Phương gọi đi COVID, em đi. The temperature can be measured in several scales, right? We have kelvins, we have degrees Celsius, and we have Faraday's, degrees of Faraday's, degrees of Celsius, and kelvins. And we can, of course, convert, from one temperature scale to another. Here I give you the equation, how to convert from the Kelvin scale to degree Celsius and how to degree Celsius to Faraday's. Remember that when we write the Kelvins, you will use the big K, but without the sign degree, okay? When we express the temperature in the degree Celsius, so you should have a very small symbol for the degree here. Similarly, we should have a small symbol for the Fahrenheit. Okay, and we know that we have the absolute zero for 0 Kelvin, which corresponds to minus 233, 115, of course, degrees Celsius. And if you convert to the degrees Fahrenheit, it would be minus 460. Okay, so, and here I give you some examples of the temperature that can be found in our universe. For example, here, this is the lowest temperature that we can record. This is around 9 to the power minus 10, minus 9, 10 to the power minus 10, 9 here. Or the temperature of our universe today, it would be in around here. This is the heat of the surface of the sun, which can be found around here, and so on. And here we estimate that the temperature when the universe just after beginning, it would be very high, very hot, yeah, around here. So you see 10 to the power 39, which is very big. So this is about the temperature. And when we talk about the temperature, we also talk about the zeroth law. Zeroth law. Do you know why it has the name of zeroth law? Why they don't start from 1? Why we have the zeroth law? Các bạn nào biết vì sao nó gọi là định luật không không? Tại sao mà nó không gọi là định luật 1 đi? Khi ta vừa tìm ra cái gì, tại sao ta lại gọi là định luật không? Yes, because we found very nice. Thank you, Hồ Thụy. Bạn gì đây? B12143. Hồ Thụy Nhật Hạ. This is because, yeah, people already found the first law. The first law already stated out, and then they, not like they invented, but they found. Okay, they state another basic law, much more basic, but because we already used the first law, people already know what is the first law. Then we have to use the zeroth law. This law is very easy. Okay, when we talk about the transfer of, when we talk about the temperature, thermal equilibrium. This law is very easy, but it was found out before we already stated the first law of thermodynamics. So if the bodies A and B are each in thermal equilibrium with a third body T, then A and B are in thermal equilibrium with each other. So you see, it's something that is quite obvious for us nowadays, but it's not. It was not obvious in the past. Okay, so if A and T are in equilibrium, thermal equilibrium, B and T are also in thermal equilibrium, then A and B, they are also in thermal equilibrium with each other. Easy, right? This is the first law. I'm sorry, the zeroth law. Now we talk about the thermal expansion. This is not something new, right, for you? You learned it so many times during high school. So this is not really the focus of this part. So I'll try to just to remind you here. We have the linear expansion, which is the tendency of matter to change its length, right? And we have the volume expansion. So this is the tendency of matter to change its volume in response to a change in temperature. And for linear expansion, we can use this equation. So the change in the length, right, of a matter, of a substance, of an object will be equal to the product of the initial length, the coefficient of linear expansion, right, and the change in the temperature. So this one. Yes. If you have any questions, please. Who is raising hand? Bạn nào raising hand thì bạn nói luôn nhé. Đâu rồi? Bạn nào raise hand rồi sao lại không thấy? Bạn Trần Ngọc Khánh. You want? Yes, I'm listening.
Yeah.
So what is your question?
Oh no, actually I forgot.
So you can remove the hand raising symbol. So sometimes I take because I will time to time I will check the chat box, okay, and I will check the list of participants. So if you have a questions, I can answer you at this moment. Otherwise, if I show the window of the participants or I show the chat box, it will hide a lot of information on my screen. Okay, so this is the way we work. Of course, for the linear expansion, we already know that for different substance, okay, for different solid, for example, they will have different linear expansion because they have different coefficient of linear expansion. For the volume expansion, the formula is quite similar. The change in the volume can be calculated by the product of the initial volume of the coefficient of volume expansion and the change in the temperature here. Okay, this is easy. But how about the heat? Actually, the heat is the energy. You agree with me, right? The heat is also the energy. So this is the energy transferred between a system and its environment because of a temperature difference that exists between them. So we have the heat flow. Here we consider a system, right? The system has a temperature Ts. And here outside we have an environment. The environment has a temperature Te. In the first case, if the system has a higher temperature, I mean Ts is bigger than Te, so then the system will lose energy as heat. We say that the system loses energy as heat. Okay. And in this case, we say that the heat is negative. When the system loses heat, we say that we define that the heat is a negative heat. It will take a negative sign. This is by convention, okay? Quy ước với nhau là như vậy nhé. Khi hệ mất nhiệt thì cái nhiệt đó được coi là nhiệt âm. Nhiệt có cái giá trị đó, có cái dấu âm ở đó. Tất nhiên là nhiệt thì không bao giờ, nhiệt lượng ấy không bao giờ âm, nhưng mà ta quy ước là khi hệ mất nhiệt thì nhiệt đó là nhiệt âm, có cái dấu âm, quy ước theo chiều đó, chứ không phải là theo giá trị độ lớn nha. Chứ khi ta nói về nhiệt độ mà nó là cái intensity or degree ấy, thì bản chất của nhiệt nó bao giờ nó cũng là phải ấy rồi. Okay, so if the system has a lower temperature, we enter in this case, then it gains energy as heat. It gains energy as heat. So this amount of energy as heat will take a positive sign by convention. Theo quy ước. So when the system gains energy as heat, we have a positive heat. Okay, please remember this convention, this agreement. Nhiều bạn nhầm lắm đấy. Về sau là tới lúc học nhiệt này, nhiều bạn nhầm dấu loạn lên. Bởi vì nhiệt nó cũng có dấu âm, dấu dương. Công nó cũng lại có dấu dương, dấu âm. Thế là loạn hết cả lên. Yeah, please remember very well. Do not make mistake when the system loses heat. Okay, so this heat is negative. When the system gains heat, this heat is positive. Okay, and of course, I think you already learned. If the heat is absorbed by an object, okay, then we can calculate this heat if we know the difference of temperature by the first formula. So we can calculate the heat that is absorbed by an object if we know the final temperature and the initial temperature of this object. Okay, this is actually the product of the heat capacity and the change in the temperature. Here we have a big C, okay, which is the heat capacity. Sorry, this is better for you. So TF is the final temperature, and TI is the initial temperature. So the delta. Now, if we consider that the object has a mass m, okay, then we can calculate the heat absorbed by an object of mass m following this formula, Q equal mc delta T. I think this one is famous, right? Q bằng mc delta T, so you should know it already. Q equal mc delta T. Here, I show on also the dimension. The heat is measured by joule. Okay, so joule here. The mass is measured by kilograms here, and the delta T, the change in temperature, is measured in degrees Celsius or Kelvin or even Fahrenheit. Then the unit of C should change accordingly. So we have, for example, here we cancel out the kilograms. Here we cancel out the degrees Celsius. Here. Finally, we also have the joule. So the rule is that the dimension of the left should be the same as the dimension in the right. Okay. In Vietnamese, we call it thứ nguyên. So the dimension in Vietnamese is thứ nguyên. So we should have the same dimension. Yeah. From the left and from the right. Here we have the small c, which stands for the specific heat. of a unit mass of material of which the object is made. Actually, when you see a specific unit, something specific mass, specific heat, specific volume, and so on, you know that we have to divide something. We have to divide the heat, we have to divide the volume to the volume of mass. Okay, to the volume of mass. Các bạn thấy là khi mà các bạn có cái chữ specific này, các bạn sẽ thấy nó luôn là một cái đại lượng nào đó chia cho cái khối lượng. Ví dụ như specific heat. Đó. Thì các bạn sẽ thấy này, nó phải là joule chia cho cái thằng này trên từng độ C ở đây. Đó. Ví dụ volume cũng thế. Nó sẽ phải là chia cho volume là ví dụ lít chia cho kg trên gì đó. Đó. Khi mà bạn thấy cái chữ specific thì các bạn phải hiểu được là cái nghĩa của đơn vị nó là như thế này. Ok. And then the amount of energy required to change the state, okay, but not the temperature. Because when you change the state of a substance, the temperature doesn't change. Khi mà một cái vật chất nó đang ở trong quá trình chuyển pha thì nhiệt độ của nó không đổi. Right? When you change the ice to water, to liquid water, the ice is still at 0 degrees Celsius, but the water also is at 0 degrees Celsius. You should finish changing the phase for the temperature of the water to be raised again. And here we can calculate the amount of energy required to change the state using this formula, Q equal Lm. Here we have the L stands for the heat of transformation. L is actually the heat of transformation. Okay. LV is actually the heat of vaporization. LV. Yeah, the heat of vaporization, I mean, when we change the states of a substance from the liquid state to the gas state, or inversely, from the gas to the liquid. So we call it the heat of transformation. For the heat of fusion, okay, we have the phase change, the phase change from the liquid to solid or from the low solid to liquid. Okay, now please take 5 minutes to do the exercise, this exercise, and then I will call volunteer to share the screen, okay, to solve this problem. I think this is an easy problem. So I will call someone to solve this problem. Please, 5 minutes. Các bạn làm bài này và tôi sẽ gọi một bạn nha. Tôi sẽ gọi một bạn, hoặc là các bạn có bạn nào volunteer Bạn nào mà lại chỉ có một dấu chấm hỏi này đây, tôi remove ra khỏi đấy nha. Sorry, BI 11006 là bạn nào? Who are you? BI 11006. Đấy, những bạn như thế này thì cho nghỉ thế chứ. BI 11250. BI 11250. Okay, remove. Alo, em đang dạy. Em không, vâng, em dạy cả chiều. So who has the answer? Okay, you do not need to turn off your camera. Please go back. Yes, I have a hand raised. Please, Hồ Công Thành.
Yes, my answer.
Do you want to?
My answer
Huh?
for the issue A is 300 kilojoule. 300 kilojoules for the problem.
I do not solve this exercise. I suppose that you will solve it. So if you have the solution, you can share to others. So and then we can verify the way you do. Okay.
Do you want the answers? Okay, so let me say.
So do you have the solution? So then I can ask you to share the screen. Em đã viết câu hỏi, câu ấy ra chưa? Câu trả lời ra chưa thì em share cho mọi người.
Dạ, em đang hoàn thành rồi.
Okay. So we wait 2 more minutes. Okay, I suppose that you are the ones solving the exercise and you verify, you validate the result. I will not do the calculation for you. I will show you how to find the answer if you do not understand, but I think this one is easy. For example, for the question A, here we have to calculate the heat that must be absorbed by the ice, and we know the mass of ice, right? 720 grams at minus 10 degrees Celsius. So we melt the ice, we raise the temperature of the ice to 15 degrees Celsius. Yeah, then how to do so? Xong chưa Hồ Công Thành?
Vâng, em xong.
Okay. Do you want to share the screen? Then I stop sharing here. Tôi stop sharing ở đây nhé, em có thể share screen nhé. Here I also received some answers. So please from Nguyễn Lê Kiệt and Trần Minh Lâm. I don't know what is written in the answer of Trần Minh Lâm, but for Nguyễn Minh Kiệt, I think I'm not sure. So we need to solve it. I'm not sure that. Sure. Em share screen đi cho các bạn xem đi.
Vâng, em share rồi.
Share chưa? Sao mình không thấy nhỉ? Okay. Okay, so here the idea, I explain, okay? The idea is that we divide into several steps. The first step, we need the heat, right? To raise the temperature of the ice from minus 15 degrees Celsius to 0, right? We still have ice, but we raise the temperature of the ice from minus 15 to 0 degrees Celsius. And then what will happen at 0 degrees Celsius? Yeah, we have the phase change. And for the ice to change from the solid state to the liquid state, it needs energy. We need to supply energy once again for the ice, for 720 grams of the ice. Then we can calculate this heat. This is the second step. The third step, now we have the liquid at 0 degrees Celsius, right? Then we raise once again the temperature of the liquid from 0 to 15 degrees Celsius. So in total, we need the heat, the energy as heat, to do 3 things.
I don't know.
Okay. If you got some fever, please go and take some medicine. So this is the idea. I cannot wait for you to have the final calculation, but this is the idea. Okay. Please remember
Oh
that.
yes, and I calculate it as
Okay.
300
Please remember that
kilojoules.
The specific heat of the ice should be different than the specific heat of the liquid water. It should be different. So I stop sharing. Okay. I will share my screen. Do you see my screen? So for the first step, you can use this equation. When it is still ice, when it's changing the phase, the state from solid to liquid, you use this equation. And once we have the liquid water, we use once again this equation. Please remember the specific heat of the ice should be different than the specific heat of the water. That's all. You should be able to find it. And for the second one, now we know that we supply a total energy as heat of 200 kilojoule. Then we want to know what will be the final state and the final temperature of the water. I already calculated, but no, actually I gave this exercise last year, and I know that the answer for this should be 0, because with this energy we cannot melt all the ice. So the final temperature should be 0. Okay, so please verify if you like. Yeah, very nice. If you calculate that 69 degrees Celsius and something is totally wrong. Maybe you forget the phase change of the ice. Please remember, okay? Now, I think we take a break of 10 minutes once again.